So here we are looking at vertical asymptotes of rational functions in a little bit more detail. Now keep in mind that these are the undefined values of the rational function. So we say that a line x equals c is called a vertical asymptote of our graph of f if f of x is approaching positive infinity or negative infinity as x is approaching these undefined values c's from both sides. So we can have a couple of different cases that we need to consider here. Let's begin by thinking about the left-hand side of c. So in a case where we have a rational function that looks like this, we can observe here that as x is approaching c from the left, the y values are growing without bound. Now, alternatively, we might also have a rational function that looks like this on the left-hand side. So from here, we can observe again that as x is approaching c from the left, the corresponding y values are growing infinitely small or decreasing without bound. Now, while we have considered what's going on as x is approaching c from the left-hand side, in order for x equals c to be a vertical asymptote, we also need to see a similar behavior on the right-hand side. And again, there are two possible cases that we need to consider. We may have a rational function that looks like this. So in this case, we can again see that as x is approaching c from the right, the y values are approaching infinity. And last but not least, another alternative for the right-hand side of the graph, our rational function might look something like this. So here we see that as x is approaching c from the right-hand side, the y values are decreasing without bound, or growing infinitely large in the negative direction. So again, in order for x equals c to be a vertical asymptote, we need to have either one of these left-hand cases paired with either one of the right-hand cases. Now, how do we find these asymptotes algebraically? So in order to find the vertical asymptotes, we need to find the factors where the denominator is equal to 0, but the numerator is not. So let's go ahead now and look at some strategy for finding vertical asymptotes algebraically. So to help us in identifying vertical asymptotes, let's consider a rational function defined as f of x is equal to p of x by q of x, where both p and q are polynomials, and these two polynomials have no common factors with the exception of 1. Then, to find the vertical asymptotes, we simply need to set the denominator q of x equal to 0 and solve for x. Now, I want to point out a couple of friendly reminders here. First, so we want to be mindful that a rational function may have no vertical asymptotes, it may have one vertical asymptote, or it may have many vertical asymptotes. So do not make any assumptions until you check this algebraically. And one final cautionary note. So we want to be mindful here that this procedure for finding vertical asymptotes is given under the assumption that p and q do not have any common factors. So just to be safe, it's always a good idea to make sure and check that your given function cannot be simplified before proceeding in finding vertical asymptotes.